Hello everyone! In this video I am going to discuss the difference between quicksort and stdsort running time. Both of these algorithms are sorting algorithms. First of the two, quicksort, relies on partition input array around pivot element and divides array into two regions. First region includes numbers that are less than partition element, and second region numbers that are greater than partition element, which can be seen on the current image. The partition procedure is called recursively for these two regions until the array is sorted. Worst time of quicksort algorithm is n to the power of 2, but average time is n times logarithm of n. The second algorithm that will be compared is stdsort. It's a generic algorithm which comes from C++ standard library. It's resides in algorithm header. stdsort utilizes intro sort algorithm, which is hybrid of quicksort, heap sort, and insertion sort. Details of its implementation can be easily found on the web. We will focus on which of these two algorithms is faster. For this purpose, I created simple C++ console application in Visual Studio. After the headers, we have quicksort implementation. Then we have defined num count, which is numbers of elements in to be sorted vector. Next, in main function we have definition of unsorted vector. Further, we have commented out a fragment of creating a text file which holds input numbers. It's commented out because for large arrays it's too much time consuming. But if you want to play with writing and reading numbers into the text file, you can uncomment it. Later we have filling in input vector with uniform distributed random numbers. Next, we have commented out a block of code that reads numbers from a file and fill in the input vector. As earlier, you can uncomment these lines. Further, we have definition of a second vector called numbers unsorted, which is a copy of the original input vector. Next line is defining a variable start which holds time point just before sorting quicksort. Below that is call to a quicksort algorithm, after which its time point written to stop variable. Difference between stop and start times point is duration of quicksort algorithm. We use microseconds as time unit. Next we have start to and stop to variables, between which is stdsort algorithm. stdsort takes as a parameter iterator to first and last element of the vector. Finally, we have variable duration 2, which holds running time of stdsort in microseconds unit. Next, we have commented out a fragment to writing to a file. Last lines of a program is displaying in console running times of quicksort and stdsort, as well as which is slower and by what factor. Let's run our application for input array size equal to 10. At the output, we see that quicksort is more than 2 times faster than stdsort. Let's run it few more times. We again see that stdsort is slower. Let's check running times for 100 elements vector. std is almost 2 times slower. Let's run it few more times. This time quicksort is slightly slower. Let's check running times for 1000 elements. stdsort in this case is more than two times slower than quicksort. Now let's try 10,000 elements array. stdsort is 1.5 times slower. Let's try 100,000 elements. stdsort is almost 1.5 times slower than quicksort in this case. Let's try 1 million elements. Now we see that quicksort is slightly slower than stdsort. Finally, let's check for 5 million element array. It takes some time. Quicksort is clearly slower than stdsort in this case. In conclusion, quicksort is faster than stdsort for small and average size arrays, for few million elements arrays and more, stdsort is faster. Thank you for watching.